Okay, so cool. So the first thing I have is I have VS Code open, which is my text editor, and first thing we're gonna do is go over like the basics of C. So this is the classic Hello World example. So for this C program, we have the main function, which is what gets run whenever you start executing a C file or executable that was compiled from the C file. So what we're doing here is we're just printing hello world, and printf is a function that's included from this stdio library. So for programs, when we want to run them, what we need to do is we need to compile them and link them. So that's what GCC does for C files, and for C++ files we use G++. So in order to compile this, we'd use gcc-o main.o, and so the -o specifier specifies the output file, and then after that we specify any source files that we want to compile. And so then we run that, and then you can see over here that we made the main.o file, and then in order to run main.o, we'll just do this, and as you can see it prints hello world. So that's basically the very first thing you do when you start programming in a new language. So as you can see, this function returns an int. So whenever you make a function, it returns a type, which can be something like an int, and it takes in a type, and it has a body. That's a function definition. So a function can take in a type like an int, a void, a char, a float, and I think that's all the types that are the base types in C. And then it can take in any number of parameters. Void, by the way, when we talk about types, void is basically the absence of a type, and int is basically an integer, so it can take on values of something of like, it can be a positive or negative integer, so we can take in 1, or it could be 2, or 0, or -1, -2. Float is basically a number with a decimal point in it, but it could also, so it would be something like 2.3 or -2.3, or basically it could be any number. And floating point numbers have a good amount of precision, so you can go pretty far out with your decimal points. But if you need even more precision past the decimal point, you'd use something called a double, which stands for double precision, and that lets you save even more decimal points past the decimal. So in programming language, there's variables, which is what I was just showing before. So a variable is a piece of memory that is saved, and it has a type and a value. So like I was showing before, if you have a variable, it has a type here, and it has a value which comes after the equal sign. So it might be something like 1.2, or for an int would be like 1. So now I've created this variable in memory with a value of 1, and since it's an int, that means there's 4 bytes in memory, and their values are going to be 0, 0. In hex, it's going to be 0, 0, 2, 0, 2, 0, 0, 1. So you don't really need to know that. All you need to know is that you now have access to this variable. So if I wanted to make another variable and we wanted to access the previous variable, we just call the previous variable by its name. So variable 2 equals variable plus 1. So since variable had the value of 1, variable 2 is now going to have the value of 2 because it's 1 plus 1. Now we can talk about why we use functions. So we use functions in order to eliminate redundancies. So if, for instance, we wanted to do something like print a name, or print a name and age or something, and we didn't want to type that out every time. So let's say we were going to type it out every time. So we have someone like Sam, and his age is print Sam, and then his age is 20, we'll say. So we're printing a name and an age, and if we wanted to do that for another person, we'd have to change this and that. So as you can see, these two things change every time I want to change it. These two things are the only things that change when we want to print something. So what we'd want to do there is we'd want to introduce a variable. So say we had a variable for someone's name, person 1 name, oh, first let me just show that this works. So here it says alright, here, make it look nicer. So here it says Sam's name and his age, and then it prints my name and my age. If we wanted to do this in a better way, we might introduce variables. By creating a variable for Sam's name, and a variable for Sam's age, and then what printf allows you to do is pass in these variables. So if we wanted to pass in a string of characters, so I haven't gone over the type car. So car is a character. So a character is anything, it's basically a single letter. So this would be an example of a character, like a capital A, or a lowercase b, or an exclamation point, or space. Any of those is a single character. And characters are specified by single quotes. What I have here is basically a string. Don't concern yourself with the actual meaning of this right now. Basically just think of it as this is a string of characters, so a set of characters in a row. So that's, and then in order to specify that you're printing a string with printf, you do %s. So in order to say that I'm using that, I'd pass person1 name, and then in order to specify an integer that you want to print, you'd use %d, and then I'd pass that integer here. So now I should be able to run this, and as you can see, even though I didn't write Sam here and 20 here, it still prints Sam age 20. And then if I wanted to do the same for me, I just take these two, change that to person2 name, person2 age, Noah 21, and then I just do this twice in a row, except instead of passing person1 name, person1 age, we're passing person2 name and person2 age. As you can see, it prints Sam then me. So this might look a little confusing to just have in your main function. So if this is something that we're gonna end up doing a lot, then we might want to put this into a function. Usually you'd put it into a function if it's more than one line, but we're just gonna show for now how functions work. So we made a function called print name and age, and in order for our function to work is we need to pass in a name and an age. So before, the type of the name was this, so we're going to take in that. So everything in between these parentheses is going to be parameters that you pass to the function. So that's what the function is basically going to have access to. So we pass in the name, and we pass in the age, and this here to the left of this is the name of your function, and this is the type that the function is going to return. So this function, we don't want it to return anything. So like I said before, void is the absence of any type. So this means that we're returning nothing. So now what we're going to be printing, so we can't access this, in order to print the name and age, we can't access it by person1 name and person1 age anymore. We need to use the variables that were passed in, which is just name and just age. So now we can use, instead of using that, we can use print name and age with person1 name, person1 age, and then should be able to run this. It should print Sam's name and age. So yeah, print Sam, age 20. So that was kind of a more complicated example than what's normally taught of how to use functions. If we wanted to do something simpler, like an even easier function, we can do something that maybe returns a value. So say we wanted to add two numbers and then multiply them by 3. So we had a function called add 2 and multiply by 3. That's going to take in two numbers, so say they're integers. We could have int num1 and int num2. And as you can see, we're going to be returning an integer. So in order to add two numbers, we take num1, add num2, and then we multiply that whole result by 3. And we want to return that, so we just use return. So these parentheses indicate that this operation is going first. So in programming, it follows PEMDAS that you learned in algebra. So parentheses, then exponents, multiplication, division, addition, subtraction. So now in order to check that this works, is we're going to print the value of this result, so %d, so we're printing the integer that is returned by this function. So now we're going to pass in two numbers, so let's do 1 and 2. So then the result of adding these two, multiplying by 3, would be 1 plus 2 is 3, times 3 is 9. So if we compile and run it, you can see that print standstill, and then value is 9. And as you can see, I'm putting the functions here above the main. That's because that you can't call a function if it's not above where you're calling it from. So programs are compiled sequentially, so it runs in top-down order. So if I try and call add 2 and multiply by 3 here, the compiler, which is what allows us to run the program, we'll see, oh, you're trying to call this, but there's nothing above me. I haven't seen that yet. So how is that going to work? So if we try to run this, you see it gives me a warning: implicit declaration of function add 2 and multiply by 3. What that means is that you're saying that exists somewhere, but we haven't run into it yet, so it might not actually exist. So that's why we normally do is we can either put the function above this, or we can use something called function prototypes. And what function prototypes are is letting the compiler know that function is going to be somewhere else, but letting it know that it exists. So here we have just the name of the function, what it's returning, and what parameters it's taking in, followed by a semicolon. The semicolon lets you know that this is a function prototype. There's no body to the function. What's down here is referred to as a function definition, because there's a body to the function that's enclosed in these curly braces. So if we do that for both of these functions, then I should not get any warnings by the compiler, and you see that we do not. So I guess now something that we can talk about is going to be the I guess we could talk about more about characters and constant character pointers or strings. So what this string is here, so I told you guys before that this can be thought of as just a string of characters. So and I also told you before that a single character is just something enclosed in single quotes, and a string of characters is enclosed in double quotes. So what this double quotes enclosed string of characters is referred to as a string literal. So what this can be thought of is this character followed by this character, or this character followed by this character followed by this character followed by the null character, which is a 0. So this, if we take a look at the ASCII table right now, let me share this screen. Okay. So if you take a look at the ASCII table, you can see that.
I don't think we see anything right now.
Okay. How about now? Nothing? Hello? How about now?
There you go.
Okay, so if we look at the ASCII table, this is a table of how characters are mapped to like the numbers. So that way you can refer to a character just by its number instead of like what the character is. So if we take a look, we can see that capital A here is the decimal number for that. So decimal number being like it's the base 10. So the decimal number for A is going to be a 65. So we can have my character A be equal to A, or we could have something like equals 65. And then these two things, these two variables, are going to be equal to the same exact thing. So something important to know is that the string literals here end with a 0 at the end, which is the null character. And that's how you can check that the string is over. So in most programming languages, the string literal will end with that null character. So you can, in order to check that the string is not, that the string has ended, you would check that if the character is the null character. And if it is the null character, then that tells you that the string is over. Okay, so now I guess we should go into if statements. So if statements are a fundamental part of how programming works. So if statements have the word if, keyword if, followed by parentheses, and in that parentheses is going to be an expression. And if that expression is true, then it's going to run whatever is in the body of the if statement. So let's print hi inside of this if statement, and let's take these things out right now. So I said if 1, print hi. So basically whatever's in these parentheses here is going to be anything that's non-zero. It's going to enter the body of the if statement. If it is 0, it will not enter the body of the if statement. So this should be print hi. So if we run it, you can see that it prints hi right here. If I change this to if 0, and then we try to run it, you can see it prints nothing. There's nothing here. So we can do that with, where the real power is checking conditions. So we could, as you can see, we have the variable here. It's equal to 1. So say we only wanted to print hi if this variable was 2. So we're going to check if variable is 2, and we print hi. And we run that, and you see we don't print hi because variable is 1 and not 2. If we change variable to 2 and then reran it, then you can see it prints hi. You can see here that we use double equal sign instead of a single equal sign like we used up here. This single equal sign is called the assignment operator. That's how you assign a number or value to a variable. Whereas this double equal sign is the comparison operator. So that's not setting variable equal to 2 here. It's checking if variable is equal to 2. And that could be a problem. So make sure in your if statements you're using double equal sign. Because that's usually what you are trying to do. So there's also some other comparison operations that you need to know about, and those are the logical OR, which is double bar sign or double vertical bars, which is usually the shifted character that's right above your enter key. So that checks if either so say we wanted to check this. So here variable 2 equals variable plus 1, so it's going to equal 3. So here we're going to check these two, if this expression is true or this expression is true. So if variable is 2 or variable 2 is 3, then we're going to print high. So if we run this now, you can see it prints high. If we instead change this to 2, then what we're going to do is we're going to see that it also prints high. So the reason for that is because this expression is true, but this expression is not true. And what an OR does is it checks if either one of those is true. If we change this to equals 1 instead, then both of these expressions are false. So then we run it, you can see it doesn't print high. So there's the logical OR, and there's also the logical AND. And what the logical AND is basically going to do is going to check if this is true and this is true. So we know both of these are false right now. Variable is 2 and variable 2 is 3. So if we run it, we can see it won't print high. If we change this one to 2, then we know this statement is true and this statement is false. So if we run it now, it still doesn't run the high. That's because they're not both true. Now if we change this one to 3, you can see, yeah, it prints high. That's because both of them are true. And we can chain multiple of these together. So if we could add more ANDs or more ORs. So say we also want to check and person 1 age equals 20. So now it will work because person 1 age is 20. But if any of these are false, because we chained them all together with ANDs, then the whole thing's going to be false. So if we rerun, you can see it doesn't print high because this statement here is false. So not all of them are true, so it doesn't run. You can also chain ANDs and ORs, but you want to usually use parentheses to say which one you're checking first. So say we want to check if variable equals 2 and variable 2 equals 3. So we're going to check if this statement is true, or the statement that person 1 age is 19 is true. So if we run that, then we should get a high, because variable does equal 2 and variable 2 does equal 3. So basically it's going to be this is true, or person 1 age equals 19. And since it's one or the other is true, then this overrides it and we print high. However, if we change this to equals 1, then this is going to be false. This is also going to be false. So it should not print high, and it does not. The importance of if statements. So all of this Boolean checking and stuff. So basically, what we call a Boolean, it's not a type in C, but it's a type in C++. It would be something like a bool. This is not valid C. Valid C. My bool. So it'd either be true or false. So basically, what a Boolean is, it's something that's either true or false. And we sort of implicitly have that in C with these comparison operators. So variable equals 1 is going to either be true or false. But since true or false isn't a correct thing in C, it's either going to be 1 or 0. So variable equals 1 would be 0 because variable is 2 and not 1. So a Boolean is basically, like I said before, it's something that's true or false, one value or another. And then we can use those same Boolean operations when we're talking about for loops, which is another very important part of C and C++. So if we wanted to do a for loop, this is what the syntax for inside of the for loop would look like. So say we wanted to print all the numbers from 0 to 9. You'd do something like this, and then you'd print an integer So I'm just going to show you what this does first, and then we'll talk about why it does it. So as you can see here, printed 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's get rid of this if statement here. So a for loop, inside of the parentheses of a for loop, you have 3 statements. You have the initializer statement, you have the comparison statement, and you have the post executing statement. So basically what we did is we created in the initialization statement, we initialized a variable called I as an integer and set it equals 0. So basically you can think of it as just before the for loop starts, you made a variable called I with the value of 0. But only the variables inside the body, only inside the body of the for loop can you see this variable I, well, because of scope, and we'll talk about scope in a bit. And then our comparison thing is we're going to, this is executed every time before you enter the body of the for loop. So we're checking if the value of I is less than 10. And then what this is doing, I++, is that's the same thing as I equals, we can do this instead, I equals I plus 1. So we'll just talk about that for now. So basically what I is, I equals the new value of I, which is the value to the left of the equal sign, equals the old value of I plus 1. So basically you're incrementing I after, and this is executed after the body's executed every time. So if you can see what it's doing is I starts out as 0, then we check if I is less than 10, and 0 is indeed less than 10. So that means we're going to execute this print statement, which is the body of the for loop. So we print to 0, then I equals I plus 1. So the new value of I equals 0 plus 1. So now I equals 1. And then we go back to the top, and at the beginning of every for loop, we check this comparison. So is 1 less than 10? Yes. So that means we're going to print 1. So we get to 1. And this goes all the way. We're going to skip to when I equals 9. So let's say 9. So say I is 9, and we're checking if we should enter the for loop. We see 9 is less than 10, so we do. We print the 9, which is the last number printed here. Now I equals I plus 1. So I is now 10 after this is executed. So now we go back to the beginning, back to the checking the comparison. So we check if 10 is less than 10. And that is not true. So we do not execute the body of the for loop, and we start executing here right after the for loop. So that's basically how for loops work. And we'll go over this real quick. I++. So when you have a number, so say we have variable 3, we can say variable 3 equals 0, or equals 35. and you can have something. There's another operator called the plus equals operator, and what that's doing. So say we did variable 3 plus equals variable. So this is the same thing as doing variable 3 equals variable 3 plus variable. So basically you can think of plus equals as the equivalent to this plus this. There's also something called minus equals, and basically instead of a plus we do minus, so variable 3 equals variable 3 minus variable. And there's also divide by equals and times equals and some others, but we won't talk about that now. And now let's talk about how plus plus works. So say we had variable 3 plus equals 1. So that's the same thing as variable 3 equals variable 3 plus 1. And C made a shortcut that's actually pretty handy, which is this is also the same thing as variable 3 plus plus. So you just got to remember, plus plus is the same thing as plus equals 1, which is the same thing as this statement here. That's also, this is called the post increment operator. There's also a post decrement operator, which is change this to a minus minus, change this to a minus equals, change this to a minus. So that's decrementing this number. There's no divide, divide, or multiply, multiply. There's only increment and decrement. So now I guess we should go over. I guess we could talk about pre-increment versus post-increment. It's not. I guess it's pretty important. So say we had variable equals variable 3 plus plus times 2. So let's comment this out right now. And then we wanted to print the variable value of variable. Since it's an int, we do %d and print variable. And if you haven't realized by now, in C you always end each statement with a semicolon, or it won't work. So given what we talked about before, what do we think this will print? Since variable 3 is 35, but we're incrementing it, what we'd probably think is this is going to be return 36 times 2, which is going to be 72. So let's run it and see what it does. And you see it returns a 70. Why is that? Did variable 3 get incremented at all? Let's print variable 3 and see what its value is. Variable 3. Alright, it's far. And then let's print a variable here. So let's see what the value of variable is. I mean var 3. So you can see variable 3 is indeed 36, but variable is 70. So the reason is because when I talk about this plus plus is a post increment operator, which means that the increment is executed after the multiplication, after the statement is complete. So we can think of this as the same thing as variable equals variable 3 times 2. And then variable 3 equals variable 3 plus 1. So as you can see, these two, this is equivalent to these two lines. So we do the multiplication first, and then we increment. But say, for example, we wanted to increment first, and then do the multiplication. So to do that is we just put the plus plus in front of variable 3, and then we can run it and see variable 3 is 36, like before, but now variable is 72 because it incremented before it multiplied. And the same goes for minus minus. That's pre-increment or pre-decrement operator, and then this is the post-decrement operator. So we talked about for loops before, so let's talk about while loops. So if we uncomment our for loop, let's get rid of this stuff. So we can recreate this same exact thing of printing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 using a while loop. So a while loop doesn't have 3 statements like a for loop, it only has one comparison. So say we want to recreate this. We have an int j equals 0 while j is less than 10. We're going to print j and then j++. So let's print some new line characters in between. So these backslash n's are just printing new line, which is basically just the same as pressing the enter key. So if we run it, you can see this is the for loop printing 0 to 9, and then here's the while loop printing 0 to 9. So these two are basically the same thing, pretty much the same thing. So what this is doing, what the while loop does, is it just takes a comparison, just like the if statement. So you initialize j to 0, just like you initialized I to 0 here in the for loop, and then we're going to check that j is less than 10. So the while loop keeps running everything in the body until this statement becomes false. So j equals, so when we first start, j is 0, so 0 less than 10, yes. So that means we print 0, and we increment j by 1. So now, when we go to rerun the while loop, we check it, 1 is less than 10, and we run all this stuff, and it's just like before. So basically a while loop can do everything that a for loop can do. A for loop just does it in a more compact way. We don't have an extra line for this, and we don't have an extra line for this in the for loop. It's all done like that. And you should use for loops when you can, and if you can't use a for loop, use a while loop instead. So we can give an example of when we wouldn't want to use a for loop and we'd want to use a while loop instead. Is say we want to print someone's name letter by letter. So I told you before that this name is SAM followed by the 0, which is the null character. So I'm gonna say, first I'll get rid of this. So we're gonna run our while loop while the name while the letter that we're looking at does not equal 0, which is the null character. So we're gonna print %c, which is printing just a character at a time, and we're gonna print person1 name. So don't concern yourself with why there's a star here or a star here. Basically, just think about this as saying this is getting the character that we're looking at, and we're starting with the letter S, and this is printing that character, and then this is incrementing what character we're looking at. So if we just run this, person, because const you can't increment. So this, why not? Okay. If we did this instead, this should work. So let's make an array of characters, and we'll go over what an array is later. So we have our array, and say we have our pointer to the beginning of the array. X is okay. So we forgot to put that there, and we're not printing characters. Okay, let's so now we look up print F and C, and this is something that you might have to do a lot. Is just you have to look up why your code doesn't work. So let's see, and debugging is also a big part of the code. So let's try printing what the value of the character is as an integer. So it's 83. So this should run pointer to name pointer. Oh, I'm very dumb. That should be does not equal 0. Okay. Okay. It worked all along. I'm just dumb, and I accidentally checked if the character is the null character when I should be checking if it's not the null character, then we print it. So this would have worked anyway. Yeah, so this should work. Because like I told you before, the initialization makes it integer from pointer. Yeah, so if we correctly define our strings, and then we make a pointer to the beginning of the string, and then we check if the letters do not equal 0, so the null character. So first we check if S equals 0, S is not, so we print it, Then we increment the letter we're looking at. Then we check A does not equal 0, M does not equal 0. And then after we increment from M, we get to 0. Does 0 equal 0? It does. So you do not run this while loop. And as you can see, I'm not using equals equals here. I'm using exclamation point equals. So exclamation point in C is the not Boolean operator. So say we had var3 again, and it's 1, and we had var4 equals not var3. Then, like I said before, so Booleans are going to be either 0 or non-zero. So var3 is non-zero, so if we not it, which basically changes it to the other side of the other type of Boolean, so it's true before or non-zero, and then if we not it, it should equal 0. So if we print what var4 is, then we should see that var4 is indeed 0. Say var3 was 0, then we want the not of var3, then it should be a non-zero, and I'm pretty sure it will default to 1. So var4 is indeed 1, because it's not var3. So here we're checking, instead of equals equals, we're checking if it's not equal to 0. And this isn't something that you'd usually use a for loop for, because you could just do it with a while loop. For loops are usually used to iterate through arrays or something, or arrays by with the iterator being the index. And that could work here, but the way we're showing it, we probably want to use a while loop. So now I guess since I've talked about arrays and pointers so much, I should talk about what an array is. So right here we basically have the same thing as an array. So an array, my int array, say it's 4, is just like a list. So here we've created an array of integers. So first we specify the type, like always, and then we specify the name, and then if it's indeed an array, we specify the size of the array, or we might not specify the size of the array. You don't have to, as long if you provide an initializer. So we're saying that we're declaring an array, which is a list of size 4. So there are 4 numbers in my list here. So when we create an array, we can assign it to some numbers. So we're assigning this array to numbers. The first element in the array is 1, the second is 2, the third is 3, and the fourth is 5. This curly, and when you're assigning to an array, you should enclose it inside curly braces. So say we wanted to print the elements of the array. Well, we can use a for loop for that. Like I said before, for loops are very useful for iterating through arrays. So first, let's actually, before we, we can do it. %d comma and percentage space. Okay, then we'll print my int array I. Let's get rid of all this. As you can see, now we are printing 1, 2, 3, 5. Hold on. So yeah, we're printing 1, 2, 3, 5, which are the elements of the array. So how are we accessing these elements? So here, when you see that we're printing an integer, because as we said, this is an array of integers. So, and then we're doing my int array I. So if we look at this for loop, we can see what values I is going to be. So if instead we print I, we see I starts at 0 and we go until it's less than 4. So if we print it, you see I is going to be 0, 1, 2, 3. So that means if we go back to here, we're printing my int array 0 with 0 inside these braces here, square brackets, and then we're printing my int array 1, and then 2, and then 3. So if we take out the array here, or take out this for loop, say we just wanted to print the first item of the array. We wanted to print the 1. So arrays start at 0 in C. So in order to access the first element, in order to access any element, we have the name of our array, and then we have open of the square brackets, and then we put the number of the element that we want to access. So if we want to access the first element, since array started at 0, we're going to put my int array 0. And if we print this, you see it prints a 1 right here. If we want to access the fourth item in the array, then we put my int array 3. Since it starts at 0, then the first element is 0, the second element is 1, third is 2, and the fourth is 3. So if we run that, you see it prints 5 when we're accessing the fourth element, which is indeed the fourth element. Now you might be wondering, we have an array of size 4. What if we try to access the fifth element of the array? What's going to be there? So let's try it. Basically, what you're going to get is undefined behavior. So you see, it prints -9 billion, or 900 million. So why is that, you might be asking? It's because of how arrays are stored in memory. So you can think of an array as being stored, well, how arrays are stored in memory is they're stored contiguously, which means that they're stored one after the other. So say we have a memory block. So in your memory, we have the block. First block is 1, second block is 2, third block is 3, the fourth block is 5. So, and then let's see, the addresses of those memories are going to be address 20, address 21, 22, 23. And then in address 24, it's going to have this value right here. Because when we went to create our array, we reserved 4 blocks of memory. So we reserved blocks 20, 21, 22, and 23 of memory. And then anything beyond that, we might have as part of our program, or, well, we have it as part of our program, but we may or may not have that as another variable. And in this case, we most likely do not have that block of memory. So what we want to, so that memory is just initialized to some random value from maybe your computer running something else. So that's why it's negative 900 million. If instead we increased it to say 5 blocks of memory, and now we have a 7 there, it should print. Now we have reserved 24, and that 24 is going to be 7. So if we try to run it now, then we see that we print 7 when we try to access the 5th element. So now you should be able to see how this for loop works. Since I is going to be 0 to 3, we're going to be printing my int array 0, my int array 1, my int array 2, and my int array 3. So it should be able to print without that in there. It should be printing 1, 2, 3, 5, which is the first 4 elements. So that's the general structure for printing a certain amount of elements in an array. Is you have a for loop, and you have an int I equals 0. So your initializer initializes your variable to be 0, and you don't have to use I here. This could be any variable. This could be hello or something. And then we check while hello is less than 4, so that's going to be 4 elements. And then we increment hello, and then we my int array index with the variable hello, and that's how you print 4 elements. If we want to print 3 elements, we change this to 3. And now it prints the first 3 elements. We could also change values in the array. If we just to say something like, say we want to change the second element. So in order to access the second element, like we said before, if the first is 0, then the second is going to be 1. And then we wanted to change it to say 42. That is how you would go about changing it to 42. So now if we print out the first 3 elements of the array, you can see we have 1, 42, 3 instead of 1. Even though we initialize it to 1, 2, 3, we later change that second value to 42, and now it's printing out 1, 42, 3. Say for example we wanted to set all the elements of the array equal to 1. All we could do is make a for loop. Since there's 5 elements of the array, we're going to use 5 here. And then we're going to say my int array I equals 1. Now if we print out all 5 elements, we should see that they're all 1. And we can see that they are all indeed 1. So what we're doing here is we're saying my int array 0, 1, 2, 3, 4 all equal 1. So that's the basics of how arrays work. They don't need to only be ints. They can be characters, like we talked about before. So this string here is the same thing as an array, like this. And there's 4 elements in the array, and if we wanted to print those all out, then we do this, and they're not ints anymore, they're characters, so we do %c, and c prints Sam. And we can change, like before, we can change, oh, it's not an int array anymore, we can just call it my array. Yeah. If we want to change this to a better name, we might change this to say an H, the first letter to an H, and now it prints superior name to Sam in every way, Ham. And that's basically how arrays work. So it can be of any type and of very large sizes, and this is how you loop through it, and this is how you change elements in the array. Now if we wanted, and like I said before, you don't have to specify the size if you provide an initializer for the array. So here it automatically determines that the size is 4 because we passed 4 elements in the initializer. We don't need an initializer, however. Say we have an array of size 4, then we could just set all of these values later. So say we wanted the first element to be 0, or the first character to be H, second to be A, third to be M, and the fourth to be null character. Then this would also work. It also prints Ham. So now I guess we should talk about our very last topic, which for today, which is going to be what an array actually is. So what an array is underneath is a pointer, and that's what this little asterisk thing is. And pointers are one of the most very important and most complicated parts of C and C++. So if we had, so we have my array here, character my array. It's an array of size 4, and this guy back in. So we can make a pointer, character pointer, my pointer, and let's set it equal to my array. Or let's do something more simple actually. Let's make an integer pointer to variable. Let's not worry about this right now. So now we have a pointer called my pointer. So it's an integer pointer. This asterisk means pointer. And this pointer is equal to the address of, which is what this ampersand means, variable. So variables too, we want the address of variable. So every variable, like we said before, has a value and it is stored in memory somewhere. So in order to get something out of memory, you need to have its address. So every variable has an address and a value. So the address is where that is stored in memory. So now if we print out what my pointer is, I think it's %p. So if we print out what my pointer is, let's see. So it happens to be 0x, which means this is a hexadecimal number, 7FFFD3B00198, and that seems like a random number, but that is where in your memory of your computer the variable called variable is stored. So in order, we could also do the same thing by just checking what the address of my variable is, because ampersand, like I said before, is an address. Let me do that, and you see it's a new number now because every time I run the program, it's not necessarily running in the same area as before. There might be other processes that took that memory that your OS operating system assigned in between the time that I stopped that previous program and ran this new program. So we can see it's still printing a memory location though. If we wanted, so what's so good about pointers is that we can access the value of what that is pointing to. So my pointer holds the value 7FFF blah blah blah. If we wanted to get the data at that memory address, then what we do is we put the asterisk in front of my pointer. And since we're going to be printing an integer, we're going to do %d. So if we run that, we see it prints 2. Right there. Yeah, prints 2. So this is taking this 7FFF blah blah blah. It's going to that location in memory and getting the value of the data at that location in memory. And that's done using the asterisk in front of a pointer. So the value of a pointer is a memory location. And if we wanted to get the data at that memory location, we use this asterisk. This asterisk is called dereferencing. So we're dereferencing a memory location to get the data at that memory location. So basically, when you have an array is reserving 4 blocks of memory, and an array is reserving blocks of memory, and the value of that array, so my array here, is going to be a pointer to the first block of memory. So if, like we had before, this is ASCII 0, then in memory we're going to have, let's say, address 20, like before, 21, 22, 23. So these are addresses. Then data at those addresses is going to be the letter S, letter A, letter M, and the null character. So at address 20, it's going to be an S. Address 21, it's going to be an A. If we're looking at this example, say we can have a pointer to a character, my character pointer, and it equals 20. So this is assuming it's stored in these addresses. So if my character pointer equals 20, that means it's pointing to the first letter in my array of 4. And we can print that letter by dereferencing my character pointer. So this is the same thing as dereferencing 20. If we wanted to print the next character, we can increment my character pointer and then print the dereferenced value of that. So after this line, my character pointer is going to equal 21, and then we're gonna, when we go to print it, it's going to dereference the address 21, and it's going to see it's an A. And we can do that again if we add 2. We do plus plus and then plus plus again, then it's going to be 22. then we go to print that, it's going to print an M. Another way we can do that is we could just put in parentheses my character pointer plus 2. So we're going to be printing we're dereferencing 20 plus 2, which is going to be an M. So we can show that in action here. So the value of my array, like I said before, is going to be the address of wherever this S is stored. So it's not going to be, it's going to be some S7FFFF number. But if we are looking at it in our example here, it's going to be, my array is going to be 20. So if we just printed my array as a pointer, because that's what my array is, just my array by itself, nothing else, it's going to print a 20. So if we, and then we set my character pointer equal to this 20, and then we go to print it, it's going to print dereference 20 plus 2, so it's going to print the M. So if we run this, we're missing a semicolon here. Here, I'll print a new line after printing the value of the memory. So it prints the 7FFF. This is the address of the S, because we're printing my array. And then we go to print the dereferenced that value plus 2, and you can see it prints the M right here. So that's basically how arrays are actually pointers. And if we go into, so one more thing about pointers is that you can, the reason this is a character pointer, this whole thing would mess up if I change this to an int pointer. The reason that is because the type of the pointer determines how it's dereferenced. So if we try to run this now, it gives you like a random, it gives you a G. It gives you a G now. And the reason that is because this pointer expects the size of the memory to be equivalent to the size of the data. So characters, I haven't talked about this, are 1 byte, and integers, depending on your computer, are going to be usually 4 bytes. So if we try to print, if we add 2 to a character pointer that's to your pointer, that's actually an integer pointer, what's going to do is going to increment by 8. So here, let's make this word longer. Okay, so if we go back to this, I'll just do this one. Okay, so yeah, we do that. You get 24, 25, 26, 27, and 28. Trying to line these up. Okay, yeah, those are pretty. Yeah. Okay, so now the addresses are lined up with the character they correspond to. The 23 is going to be the second M, 24 is the Y. So let's do just plus 0. When you run it, it's an S. Because we're still printing a character and we're dereferencing it to be this plus 0. So it's still going to be pointing to this first character, this S. But if we did plus 1, since characters are 1 byte, integers are 4 bytes, we should be printing the second M, because that's 1, 2, or we should be printing a Y, because that's 1, 2, 3, 4 characters later. Because if it was a normal character pointer, it would just increment the value by 1, but since it's an integer pointer, we increment the memory value by 4. So let's print this, see if it's indeed a Y, and as you can see, it is a Y. So let's print what my character, yeah, let's just show that off. So if we print my character pointer, and then we print my character pointer plus 1, they should differ by 4. Need new lines. Okay. Okay, so you see this first number, it's the same as this second number. The only difference is this ends with an A and this ends with an E. And if you know hex, E minus A, that's the same thing as 14 minus 10 is 4. So these two numbers indeed differ by 4. If we change this instead to a character pointer, they should only differ by 1. And as you can see, this is an A, and after an A comes a B. And we're printing the second character now, which is an A. We change this to a double pointer. I'm pretty sure double is 8 bytes, so that means we should be printing this space here. And we are indeed, we can see that here, let's change this to an actual, let's change that to a V or something. Okay, I think we need to cast this. So if we into hold on. Okay. Oh, I guess it is 16 bytes. 4, 8. Yeah, I guess 1, 2. Oh wait, I didn't line it up right. Yeah, it should be this second one here. So it's this D here. So yeah, it's 8 bytes. I changed this to V. Yeah. So we're going 8 bytes more because doubles are size of 8 bytes. So we're going to be printing this T here. Okay, I think that wraps it up for basic C stuff and some advanced C stuff, which is the pointers. You should get very familiar with pointers because they are definitely the hardest part of C for most people, and they're definitely something that you need to know because they're very important. So I guess that wraps it up for this lecture. If anyone has any questions or something that I should add, let me know.
Cool. You're gonna add more. You're gonna go more into detail on pointers later, right?
Yes.
Or is that it?
I guess I could. Yeah.
Well, no, I'm just asking because you put you're gonna talk about pointers and memory in day 2, so I was just wondering.
I think I changed my mind on that.
Okay, just
Yeah.
wondering.
Okay.
Cool. Yash and Morgan, can you guys